Hello students, we are going to learn about the soft computing in this module. Today we are going to see the definition of the soft computing, what are the components, features, and what is meant by the hard computing, and what the features and why we are going with the soft computing, and what are the different schemes of the soft computing. Now, what is meant by soft computing? So it is an emerging approach which can be applied for the computing technique where we are of uncertain and imprecision. Okay, so what is meant by uncertainty and imprecision? So the in uncertainty implies that we are not sure about the result, or we cannot predict more, or we don't know like whether it will happen or not. So that is called as uncertainty. And coming to the imprecision, which implies that the result may or may not be accurate. So in the traditional computing system, there will be certainty and accuracy, but in the soft computing, we don't have the like certainty and accuracy. So we will work only with the task or problems which are of uncertain and imprecision. So finally, we can say that it is an emerging technology which works on the problems which are uncertain and impressive. Okay, imprecise. So what are the different real world problems we are going to model? Okay, so the models which are very difficult to model mathematically. Okay, so the complex problems which cannot be modeled mathematically, we can go for soft computing. So whenever we are talking about the computing, so the basics will start from the logic. So the logic will be derived from the maths. Okay, so the problems which are not resolved with the mathematical model, we can go with the soft computing. So the basic aim of the soft computing is to exploit tolerance. So we can tolerate imprecision, uncertainty, approximate reasoning, and partial truth. So as I said, imprecision means not accurate. Uncertain means we are not confident or we cannot predict. Approximate reasoning. So we don't have the complete reason for that particular problem statement, or we don't have the proof for the hypothesis. And partial truth. So it is not completely accurate. So we can take, if we have 50-50 chances, we'll say in the probability, we'll have 50-50 chances. For that, we'll go for the soft computing technology or in order to make the decision. So if you see the diagram, these are the basic components of the soft computing. So we'll have the fuzzy logic, genetic algorithms, artificial neural networks. All these techniques will work on the soft computing methodology. So all this will don't have the complete prediction value, or it may not have the certainty, or it will won't have the precision values. Okay. So if you see the left side, so what are the basic features like what we are going to do? So in this particular thing, yeah, if you see here, first we'll go for the recognition. So what the basic problem recognition, then we'll diagnose, like we do the analysis part, then we'll go for the planning. Then it is an example for the robot control. So what exactly will work for the robotic control methods? And finally, we'll predict. So if you take any other problems like this, so we have to identify the problem, we have to analyze the problem, we have to plan how it should be executed or resolved, and we can go for the control mechanism. And then finally, we can repeat the, like we can get the result. That is, we can get the predict the result. So what are the basic properties of the soft computing? First one, as I said, it is a collection of methodologies like how we are working synergistically, not competitively, and it will reflect in the following principles. First one is exploit the tolerance, like it will be tolerant for the imprecision, uncertainty, approximate reasoning, and partial truth. In order to achieve tractability, means you can track any kind of the problem which is more complex, and robustness. So this can be work under any conditions. And third one is close resemblance with human-like decision making. See, when you take an example, when we are working with the system, whatever the command we are giving, it will work accordingly. But human will not work like that. So the human can make the decision with the minimum requirement of the input. Suppose if you require 10 values for the input, he can predict the result with only 5 or 6. But coming to the system, it will say that I have to get all the 10 inputs. So like that, this particular soft computing will work like a human decision making system. Next one is it will provide the complete flexible information processing capability. Like it is exactly opposite to the real world computing. So what it will do, whenever you are having the ambiguous data, it can work. Or if you have uncertain situations, it will work. So all our real world problems are equivalent to the ambiguity and uncertain issues. So all such kind of problems can be done with the soft computing. So the soft computing is a basic foundation for the artificial intelligence, because the artificial intelligence is an resemblance of human intelligence. So what we are doing, we are converting the biological intelligence which is provided within the brain to the artificial intelligence. So he's the person who have started the soft computing. His name was L.A. Zeda. So he introduced the soft computing, which is conventional from the hard computing. He said that in the hard computing, we have certainty, we should have the complete truth, and it should be accurate, and there is no problem of exact results. So all these opposite words he took and he modeled the model called soft computing. Now, why we go for the hard computing? So what is meant by hard computing? So when we are talking about the hard computing, as I said, the input should be like this, the output should be like this, and you'll have complete certainty of that particular occurrence of the problem. Everything will be there. So what we are doing, mathematical models. Like if you take an example, how we will do the multiplication or division, modulus, what are all the things we'll get, you'll give some definite input and you'll get the output. So this will be the real ideal cases. But coming to the real world problems, these are not ideal. So these are non-ideal, where we have to predict the result, where we have to work with the ambiguous data, and we don't have the accurate results for that. So exactly the opposite word for the soft computing is hard computing. So this was the first computing system where the soft computing will depend on the hard computing, because some of the techniques which we will use in the hard computing may be used in the soft computing. So what are the features of the hard computing? Real-time constraints, and it should have the accuracy, and it should have the precision and exact calculations, and useful in the critical systems. Okay. So where if any complex system is there, you have the complete accuracy, complete precision, then we can work with the hard computing. So at the same side, if you have the complete system complex problem is there, but we cannot have the complete data related to the problem. In that case, you have to switch to the soft computing. So what are the different problem solving techniques? So different problem solving techniques which are supported by your hard computing and soft computing. If you see here, we have the precise models, we have the approximate models. So in the hard computing, we'll have the precise models, you'll have the symbolic logic reasoning, traditional numerical modeling and search. So in the traditional numerical modeling, whatever the algorithms we are using now, okay. So basics algorithms, all the mathematical formulae, all this comes under your this numerical modeling and search. Logical reasoning. So what are the logic we are going to build in the programming languages? So all this comes under your precise models, which are in the hard computing. Now, next one is the approximate models. So in this, you'll have the approximate reasoning, functional approximation, and randomized search. So the best example I'll tell you here, when we are talking about the precise model, suppose if you take a binary search or linear search, you'll have the complete structure, you'll have the input, and you know how to do that, and you know what the result will get. But coming to your randomized search, we don't know. Randomly we pick the element. On what basis you are picking the element also, we will not formulate, right? So this will be, and the reason for picking that particular value will be not accurate. Like we'll say approximately, just like that I took that particular value. So what are the different steps? We have seen the steps for the soft computing. So what are the steps for the hard computing? So first you have to define the class decision problem. What are your problem is there? And identify the options. So what are the criteria for rating option? Like if you're taking any complex problem, how you are going to develop the criteria, how you are going to develop the execution plan. Finally, whatever you get the result, you have to evaluate again against your plan. Then so here what we are doing, select the top rated option. So suppose if here I have developed three criteria plans and I have evaluated all the three criteria plans, out of which one was very good and which whose rating was excellent. So what I'll do, I'll only take that particular option here. So this is a complete process of the hard computing. Now, why we are going with the soft computing? Okay, so the first and foremost solution for any logical or complex problem is mathematical model. If your mathematical model is not supporting any complex problem, we have to go for the soft computing. That is the first one. Okay, so mathematical model is not working means you have to go with the soft computing. Second one is more complex systems. Suppose if I take an example, human brain. So how the human brain can be modeled with the mathematical or mathematics? No, it is highly impossible because it is completely related to the signals and how it is going to process and what type of situations the output will be given and how the output will be predicted. So these cannot be exactly designed with the traditional, that is conventional or hard computing technique. So for that case, we have to go for the soft computing. Now, what are the basic things when we are going for the soft computing? As I said, exactly the soft computing works as the human brain. So first one is what the typical human can do. He can take the decision. He can give some inferences from the previous situations. What is meant by inference? Okay, I'll say that suppose if you have done this, this was happened. Okay, so in your experience, you saw this like whenever you are writing your exams or you're doing some task, you know that this may happen like this or like that, or another way also it may happen. So that experiences will be stored in your brain. So these are all comes under inferences. So who can store this? Only the human can store, and he will tell in the next experience, no, no, I have done like that. It was happened like this. So we should not do like that. So this is here. And expertise. So in any area, expertise will be there. Like we are taking so many domains, doctor, banking, education system, all these things. So the human can expertise in one domain and adapt to the changing environment. See, we have so many lot of generation gaps. So all this we are adapting and we are always learning to do better and social behavior. So which we cannot do any algorithm or we cannot provide any mathematical model for that. So all these are human challenges or human learning models or human complex tasks. So these all can be achieved with the help of the soft computing. So if you see the down one, we have one and two. So taking decision and inference from previous situation, we can use the fuzzy logic. In order to become an expertise and adapt changing environment, we can use a neural network. And learn to do better and social behavior, we can go for the evolutionary algorithms. So how we are completely matching our human brain or human intelligence with the soft computing with some techniques like fuzzy logic, neural networks, and evolutionary algorithms. So finally, what are the basic schemes where we are going to use this particular soft computing? So all this comes under your neural computation, evolutionary computation, and fuzzy logic algorithms. So these are all differently from your natural computing area, and these are all belongs to your basic soft computing that is related to your artificial intelligence. So main aim of the soft computing is to utilize in your artificial intelligence and robust intelligence systems to design, and we can go for the advanced learning for fuzzy logic, evolutionary computation, and also robotics. Okay, thank you.